Today we're going to be talking about data distributions, and it's just a lot of vocabulary, but it helps us to understand the parts of displays and how to understand the pieces within. So let's jump right on in. A cluster is data that is grouped together. I think about grapes for some reason with this, but because you buy a bunch of them, it's bunched or grouped together. Here is an everyday picture of a cluster with some data outside. This histogram shows there's a gap here, so there's a cluster of your data points here. And again, on a line plot, we have a cluster here away from some of our other data points. The next word we're going to talk about is what I just mentioned, a gap. Gaps are pretty self-explanatory if you look at these images. Gaps are empty areas in a data display. So here, when you lose teeth, you have gaps in your teeth. Here it shows that same display at the beginning, but instead of having a cluster, we have the gap. There's an empty space in our graph. There's an empty space here in our line plot. Peaks. It's like a mountain. It's the very tallest part of your data display. So it is the highest point of the data display. In this one, this is the tallest bar in our histogram, so this is the peak, and the peak here at 25 is higher than these two. That's why this is called the peak. Next, we're going to talk about outliers. Outliers lie outside of the data. It's much larger or smaller than most of the data. So here, it got cut off. We have a group of birds, and there was supposed to be a little bird over here. So I can't draw, but that'll be our bird. Okay? So it's outside all of the other birds. There's a big group or a cluster, and the bird is out here. If you look over here, we have an outlier to the left. It is much smaller than the rest of our data. And over here, we have an outlier to the right. It is much higher to the right of the rest of our data. Again, most of these terms have a very common definition that could be used outside of math, but it's also very useful when it comes to looking at data displays. The next term we're going to talk about is symmetry or symmetrical. If something is symmetrical, both sides of the data look exactly the same when you split it down the middle. Imagine that you would split something down the middle and fold it over. It would be exactly the same. So we could split it this way and fold it over. That picture would be the same. Or we could split it horizontally. No, we could not. It would not be the same because of the designs on it. So this one could only be vertically symmetrical. Okay, the dotted line here shows where I have split this histogram down the middle. If I fold it over, my pieces will match. Same thing here on my line plot or dot plot. This is the middle because that's the 25 is the middle of 20 and 30. And if we fold it over this line, everything matches. We have the two data points here, nothing here, nothing here. We have one data point, and then we have two data points. That is symmetry or symmetrical. The opposite of symmetrical is asymmetrical. And that's where both sides of the data are different when you split it down the middle. So if we were to split this house down the middle, do you see how if we folded it over, it would be totally different? We got some windows over here and a door over here. They would not match. If you look over here, we split it down the middle. This would match, but when I folded this piece over to here, those don't match at all. Neither do these, and these are different as well. If we split this line plot down the middle, you can tell right away that the first line we have, the first side, we have one data point up here and nothing here. So it'd be very, very different. I don't know why there's an X up here and not down here, but oh well. It would not be the same on both sides. Okay, when something is asymmetrical, it could be skewed. So we're going to talk about what skewed means. We have a left skewed and a right skewed. And both of them include outliers. So if you have an outlier, you're going to have skewness. And when you have outliers on the left side of your display, it is called left skewed. They talk about the area getting to the outlier as the tail, and the tail is on the left. So if you take our little animal here, I really don't know what that is, but we have a bunch, and then we have the tail here. The tail's on the left. If we're talking about data, this histogram shows we have a nice tall cluster here, but then the tail is out here. So imagine this shape and the shape of our little animal over there. Same thing for this line plot. We have a nice cluster and then a tail. Tail is on the left, so this is your tail, and this is your tail. Alright, last we're going to talk about right skewed. That's where your outliers are on the right. And I have this cute little squirrel eating. We have a lot of the data here. It goes down and then levels way out here for the tail. Histogram, you see how we have the bunch of data and then the tail is on the right. Same thing on our line plot. We have our bunch of data and then it levels way out here to this outlier. There's your tail. So since the tail's on the right, we have right skewed. If we have a tail on the left, then it will be left skewed. All of your data will have a general shape, and that's what we're talking about with this whole page of terms. It will be symmetrical or asymmetrical. If it's asymmetrical, look for an outlier, and if it has an outlier, look what side the tail is on to get to the outlier, and that will tell you if it's left skewed or right skewed. These terms we'll talk about more as the unit goes on, but these visuals, these images are great to have a mental image of what you're looking for when we're talking about these terms. Practice those as we go along, and I hope this helped you to understand the terms for data displays.